and welcome to this presentation on sustainable software engineering. I'm really excited to be here to talk to so many of you about what sustainability means in the world of software engineering and what position we can take as software engineers in the broader sustainability movement tackling climate change. So a little bit about myself. I'm a cloud platform engineer with Goldman Sachs, specializing in Amazon Web Services. I'm of course an aspiring public speaker. I did my first lightning talk with the London Java community late last summer and now braving through my first meetup talk. How did I discover sustainable software engineering? Is a question that I've been getting a lot lately. Long story short, I was inspired by a sentence from a podcast. The podcast is not even about green IT, it was about cloud monitoring. The founder of this cloud monitoring made a transition from security. While discussing his transition, he said something along the line that how he can now use his expertise to make a real impact tackling climate change. This one sentence really resonated with me. You can ask my friends that I'm a little mean when it comes to single-use plastics. I always give them grief when I see them use plastic bottles. However, my friend's grief hasn't really gotten me anywhere. So after that one sentence, I started my journey towards a sustainable software engineer. Let me quickly paint you a picture. For the past several years, we as coffee drinkers are increasingly more educated about the consequence of single-use to-go cups. More and more of us are bringing our own reusable ones when buying coffee, going with a sustainable option. Similarly, for the milk we have with our coffee, more and more of us are now choosing a non-dairy alternative, such as soya or milk, such as soya or oat. There are many more daily scenarios where we're empowered to choose the eco-friendly option because we are informed and educated. But have you ever gone to design review, a technical discussion, or a sprint planning and choose the more sustainable way of doing something? So I guess that brings us to what I would like to cover in this presentation today. I would like to cover the principles of sustainable software engineering, then going over examples of what others are doing in this space, before sharing the two philosophies that complement the sustainable software engineering. Finally, I'll share the resources that have helped me so far before wrapping up the talk with a short Q&A. So what does sustainability mean in the world of software engineering? Up till recently, there's no industry-wide agreed definition on what SSE should entail. A lot of research has been done in the space, but people are noticing that everyone has slightly different definitions when it comes to calling something green in the software engineering context. Last year, a group of people from Mozilla Foundation and Microsoft came together and gave SSE the following definition. Sustainable software engineering is an emerging discipline at the intersection of climate science, software practices and architecture, electricity markets, hardware, and data center design. The 8 principles are a core set of competencies that allows us to define, build, and run sustainable software independent of application domain, the industry we work in, the organization size or type, whether the software is hosted by ourselves or on-prem or by a cloud provider, or the programming language that it's going to be choose. With almost every single company is going through digital transformations. By 2040, the ICT sector is expected to account for 14% of the world's carbon footprint, up from about 1.5 in 2007. So the first principle of sustainable software engineering is all about carbon and how building applications that are carbon efficient can have a meaningful impact. Carbon is basically a shortened way to describe all greenhouse gases. Greenhouse gases are gases in Earth's atmosphere that trap heat. They let sunlight pass through the atmosphere, but they prevent the heat that the sunlight brings from leaving the atmosphere. So essentially, greenhouse gases act as a blanket, increasing the temperature on the surface of the Earth. Do remember that this is a natural phenomenon, but due to the crazy amount of human-made carbon pollution, the global climate is changing at a rate that's too fast for us humans, animals, or plants to adapt. There are many different types of greenhouse gases. The most common one is carbon dioxide. And just to make the calculations easier, we normalize all greenhouse gases to carbon dioxide equivalent. The goal of the Paris Climate Agreement is to reduce carbon pollution so that the temperature increase stabilizes to a 1.5 Celsius increase by 2100. The temperature increase on Earth is dependent on the total amount of carbon we have in the atmosphere, not the rate at which we're emitting carbon. So to completely stop the rate of temperature increase, we need to stop adding carbon to the atmosphere or achieve something that's called net zero emissions. Net zero means for each gram we add into that, for each gram of carbon we add to the atmosphere, we also have to take away 1 gram. So the mass of the carbon in the atmosphere stays fixed. So to speak, to build carbon efficient application is to minimize the amount of carbon emitted per unit of work. Everything we do as software engineers on the job requires electricity. And most of those electricity is still produced through the burning of fossil fuel and is responsible for 49% of carbon emitted into the atmosphere. So the second principle is about building applications that are energy efficient. All softwares, from applications running on mobile phones to the training of machine learning models in data centers, they all consume electricity during executions. One of the best ways we can reduce the amount of electricity the software consumes is to make the applications more energy efficient. And here we are using kilowatt hours to measure how much energy is used over a period of time. The third principle is about consuming electricity with the lowest carbon intensity. What do we mean by carbon intensity? The carbon intensity of electricity is a measure of how much carbon emissions are produced per kilowatt hour of electricity consumed. One thing to note is that not all electricity is produced the same way. Some electricity has higher carbon intensity because it is produced by burning of fossil fuels. Electricity produced by renewable sources such as wind or solar emit no carbon during the process. If I plug my laptop directly into wind farms, then the electricity consumed would have carbon intensity of 0. However, most of us cannot plug anything directly into wind farms. Instead, we plug them into power grids that are supplied with electricity from a mix of sources. Two things to note. Firstly, carbon intensity changes by location. As shown on the slide, you can see that the north of the United Kingdom on average has cleaner electricity, therefore lower carbon intensity. Secondly, carbon intensity changes over time. For example, when it's cloudy or the wind isn't blowing, carbon intensity increases because the electricity in our power grid mix comes from fossil fuel. So if we can be flexible with when and where we run workloads, we can then choose how to consume electricity based on the intensity of carbon. For instance, we can choose to host a big wind farm at a location with the lowest carbon intensity. We can also choose to run a daily batch job at a time frame that is least carbon intense. There are several services available that allows us to obtain real-time data on carbon intensity. For example, in the UK, we have Carbon Intensity API. So if we shift our demand based on carbon intensity, we can achieve carbon reduction of as much as 45% to 99%, depending on the number of renewables powering the grid. The fourth principle is embodied carbon. Almost everyone's first thought when a mobile app is laggy is, I should probably buy a new phone. The average lifespan of a computer or mobile phone is estimated at 2 years. As developers, we can influence the lifespan of end user products by making sure our applications are not too slow on older models. Because when we calculate the total carbon pollution of a device, we account not just for the carbon emitted during the running of the software, but we also account for its embedded carbon. Embodied carbon is the amount of carbon pollution produced during the creation and disposal of a device. And reports have shown that nearly 3/4 of the mobile phone's total carbon pollution is accounted for during the manufacturing phase. So the fourth principle is all about encouraging us, the developers, to build applications capable of running smoothly on older hardware.
Sorry, I don't understand.
I think I just triggered my Google alarm, sorry. Let's jump to the seventh principle. Demand shifting, as mentioned in the third principle, is when we move workloads to a region or time when the carbon intensity is less. Demand shaping is a similar strategy, but instead of moving workloads to a different region or time, we shape the demand to match the existing supply. If the supply of renewable energy is high, let's do more in our applications. If the supply is low, why don't we try limit the compute? A great example is YouTube. When you are streaming a video, by default, rather than streaming at the highest possible quality at all times, the application often shapes the demand by reducing the video quality to prioritize audio when the network bandwidth is inadequate. We can also consider presenting eco modes to users. I'm sure most of you have been using eco modes on a regular basis, such as when washing clothes or driving cars. Software applications can also have eco mode, which when selected can potentially behave in two ways. We can present the user with information, so they can make a decision on choosing to limit the features when the carbon intensity is high. We can also have the application automatically make decision to pause on some features in order to reduce carbon emissions. In short, demand shaping is related to the broader concept in sustainability, which is to encourage us to reduce consumption. We can achieve a lot by becoming more efficient with resources, but at some point, we just need to stop what we're doing, change our behavior, and take less. Here are the rest of the principles. I don't think we have enough time to go through all of them today, so I've picked what I think is the most important to get across, which is carbon, because everything we do comes with the carbon price. So what is everyone doing? How can we relate? As I said, sustainable software engineering, not necessarily a new discipline, but a discipline that has gained a lot of traction lately due to the current climate crisis. There are many defined and tried patterns for companies or products to migrate to a more sustainable option. Nevertheless, for the past several years, many companies have made environmental sustainability one of their key OKRs. For example, the Mozilla Foundation. In March 2020, they officially launched a dedicated environmental sustainability program, where they set out 3 strategic goals. Firstly, they look for ways to reduce and mitigate their operational environmental impact. Secondly, they are training and developing their staff to build with sustainability in mind. Lastly, they look to raise awareness for sustainability internally and externally. Microsoft is another company that has made some daring commitments. It pledged that by 2030, Microsoft will be carbon negative, and by 2050, it would have removed all the carbon it has emitted since the company was founded back in 1975. January last year, Azure announced the availability of Microsoft's sustainability calculator for their enterprise customers. This calculator gives their customers insight into carbon data associated with their Azure services. Currently, Azure is the only cloud provider that offers this transparency. Stripe is an online payment processing platform. It became carbon neutral in 2017 by purchasing enough carbon offsets to reach net zero emissions. From earlier, net zero means every gram of carbon we add to the atmosphere, we have to also take it away. Stripe offers a product called Stripe Climate, which allows its user to help tackle climate action by directing a fraction of their revenue towards an initiative that permanently remove carbon dioxide from the atmosphere. And earlier this month, it was announced that Stripe Climate is now available globally. Whole Grain Digital, a boutique digital agency based in London, is one of the early birds in this field. It has applied many sustainable principles in the web design space. It has also built something called the website carbon calculator. This calculator estimates a web page's carbon footprint by using 5 pieces of data. Data transfer over the wire, energy intensity of web data, energy sources used by data center, carbon intensity of electricity, and website traffic. Here you can see that BBC News' website is a rather dirty one, that it is estimated to produce nearly 230 kilograms of carbon dioxide equivalent per year, which will roughly take 11 trees to absorb over a year's time. So why should we care? Companies are starting to connect the dots that by applying sustainable principles, the added benefits are not just applications are more resilient, more performant, but they're always almost cheaper. So the first philosophy is that everyone has a part to play in this global crisis. I'm a firm believer that it's better to have a majority of people trying to do the right thing than the minority of super greens taking action. The second philosophy is that sustainability should be enough to justify our work. As sustainable software engineers, we realize that there are many advantages on choosing to build applications with sustainability in mind. But the primary reason we are practicing SSE is to tackle climate change. Everything else are just added benefits. So let's go back to buying a cup of coffee mindset. By educating ourselves on how these principles can be applied on a regular basis, we can be empowered to consciously make sustainable decisions going forward, resulting in our sector producing significantly less carbon. So what's next and how can you get involved now? Principles.green. I do encourage you to go check it out and familiarize yourself with all the 8 principles. They also have links to examples on how these principles can be applied. Climate Action Tech is a vibrant online community for anyone working in the tech sector. Its purpose is to empower technology professionals like us to play our part. Oh, sorry. Again, Azure of Microsoft is leading a pack here where they're joining the dots of cloud computing and its carbon benefit. Thank you so much again for listening. And if you're interested, please do reach out or check out any of the websites that I've mentioned. Thanks, guys. Do I just take questions now or like, I don't know how much?
Yeah, does anyone have any questions for Sarah? Thank you very much, by the way, Sarah. That was a fantastic eye-opening talk.
Hi, Sarah. This is Jay here again. It is a nice talk, actually. This is something I have come across something new today. Thanks for that. Actually, as a developer, I never thought of like writing applications which will be like, emitting zero carbon. So my question is like in this COVID situation, like all of us having online meetings, so the company like Zoom and other companies, are they also considering zero carbon emission at the moment?
I'm actually not sure. To be fair, like sustainable software engineering and green IT has been around for a long time, but it has come back on everyone's radar, especially with COVID and how reliant we are with internet. And I think with the US now joining back into the Paris Climate Agreement, a lot of those US companies will start considering sustainability, one of the key OKRs. So hopefully in the really near future, we can see more companies taking initiatives on how we can like reduce our sector's carbon emission, basically.
Thank you, Sarah.
But I do have one tip.
Yeah.
When you watch Netflix or anything, right, if you stream it in standard definition, instead of high definition, you can reduce the carbon intensity or like the carbon emission by like 85%. It is insane. And then like, if possible, if you dial into a huge Zoom meeting where like showing your face is not important, I do encourage you to turn it off as well, because you can again reduce carbon emission by a lot just by not showing, not using the video.
Yeah, that's why I hide myself. Thank you, Sarah, for answering.
No problem.
And for those of you without a mic, you are free to type your question in test chat as well, and we will go through them too. Lester just asked, can you share the slides as well, please?
Oh yeah, sure, definitely. I will get in touch with the London Java community and I will share them. But I really do encourage anyone remotely interested in like sustainable software engineering to check out climateaction.tech. They are like a really vibrant Slack groups. They have like all kind of experts in this group. And every time I ask the questions, I will get some really detailed and professional answers back in like 5-10 minutes. It's like, I think right now there's like 3,000, 4,000 people in it. And every week there's just more people joining. And it's great to see that more people want to take part. Like I was exactly the same, that I didn't know this was a thing till like late last year. And it is really eye-opening and like how much we can achieve. And by normalizing the conversations, I'm really sure like we as software engineers can achieve a lot, helping like tackling climate change.
And Sarah, once Karsten starts later, maybe you can also share the links in test chat as well, for everyone's references.
Oh yeah, sure, I will do.
Fantastic. Any other questions before Karsten starts his talk? You can also ask later after Karsten is finished as well, if you have questions for Sarah later. But since there's no questions for now. I think we will pass on to Karsten, who will be talking about how should Java developers build front ends for web, mobile, and desktop. Thank you, Karsten, and thank you, Sarah.
Okay, thank you. I hope you're hearing me now. Everything's fine.
Yep.
Can you just give me a
See
sign?
your screen as well.
Oh, wonderful. So once I start talking, I can't see you guys anymore. So if you have anything, please use the chat or just speak out, because my presentation is going to go full screen. So
yeah, I'll shout at you for anyone who's screaming for help in chat as well.
Wonderful. Okay, so here we go. Well, first of all, thank you for inviting me here. And today I want to answer one question, which is how should Java developers build front ends for web, mobile, and desktop today? So if you're interested in the slides and the videos, if you want to get some more information, if you want to help on getting started with some of the frameworks I'll be talking about, or if you want to subscribe to my newsletter, then please punch in this URL or take a screenshot of this QR code, not a screenshot, pull out your camera. I'm going to show this again at the very end of the presentation. So I'm going to move on, and just a quick word of advice. I've been, as it is custom, working on my presentation until the very meeting. So please wait until tomorrow. There's already some stuff on that talk page, but I'll add more stuff on one framework and more samples and more additional material on the other. So I'm going to move on now. Now in the abstract, I said that I'll be talking about 3 different scenarios. So here we go. The first scenario is that we just want to build a web application from scratch, greenfield, and what should we use that? Second one is we already have a web application, but we want to add native iOS and Android apps on top, again, from scratch. And the last one is we've got a web application and we're not really sure what to do about desktop. So those are the 3 scenarios to which I'm going to give you advice. And whenever you hear advice from somebody, it's good to ask, what's my angle? So why do I give advice, and what's my background, my angle, my context? So I've been a Java developer for 22 years, and I put 3 full stack projects into production over the last 4 years. My 4th one is going to go live this summer. I'm not affiliated with any of these projects I'll be talking about. I'm not selling you anything here. You know, I've got no course or book or something to push here. So I'm just going to give you advice. So really, I give you options for your next project. Now, what you need to do is that you need to apply your own criteria, you know, technical, legal, ethical, and evaluate whatever choices you're pondering in your environment. And then you got to make your own choices. Now, this is important, and that's why we saved this for later on our summary slide. So 2 questions we're going to be asking to push this talk forward. Number 1 is how can we build front ends today? And number 2 is how should we Java developers build front ends today? So when we talk about front ends, we're going to first define what kind of applications and which devices are we really talking about. So it's really these kind of applications here, which is, you know, data entry, data retrieval, no games or media applications or anything fancy like that. So if you were to look for examples, I would say maybe an expense filing application, an issue tracker, you know, something here. So we're not doing Word, we're not doing PowerPoint, we're not building, you know, SAP or something, but, you know, applications of that caliber. And the devices are as follows. We're going to be talking about PC, Mac, Windows, and Linux. And of course, we're talking about mobile these days, iOS and Android. So to sum up, we are looking for, you know, expense filing, issue tracker kind of applications, and on PC and mobile. And so that also is going to go onto our summary slide. So we answered already a bit of the first questions, you know, what kind of front ends today, really what kind of applications are we talking about? Now, how can we actually build these applications? Well, we can go save. And what does save mean? Well, save means stuff is still around in 5 years. So the tools we use are still around in 5 years for sure. Well, there are two options here. The first one is the web. We can build a web application, and we're sure in 5 years we can still build web applications. The other option is going native. So as you can already see, it's not one native application, it's actually 5. So how do these two options compare? Well, on web, we've got one code base, which is really good. On native, we've got 5, which sucks. The web generally produces applications that are slower, and the native ones are fast. Web, we have less features, especially on mobile. For instance, on iOS, you don't have push notifications, you don't have background sync. You can only generally store, maybe 50 MB or so on mobile browsers. On native, you've got all the features. The world is your oyster. We use JavaScript on web, which is bad, but on native, we have 5 different languages to deal with, which is even worse. The debugging experience on the web is bad because, it's hard to debug a Java application running on a phone that you have in your hand, whereas on native, debugging is something that they excel. So that is going on to our now, if you look at this slide and you say, well, can't we just combine the best of both worlds? And the answer is yes, we can. So if you combine all of these things, then that's what cross-platform is called. And of course, you're skeptical because if something sounds too good to be true, then it probably is, and it is, I can tell you that. So now we're looking at web frameworks here, and I think I've already heard them mentioning by somebody, in alphabetical order. It's Angular by Google, React by Facebook, and Vue.js by a single person, spearheaded Evan You. And then for cross-platform frameworks, there's 4 that we're going to take into account, again in alphabetical order: Flutter by Google, JavaFX by Gluon, React Native by Facebook, and Xamarin by Microsoft. So here's a disclaimer. I only worked with 2 of those frameworks, Angular and Flutter. And so the other frameworks I just researched. So I've got no project experience with those. Now, when we talk about framework, I think it's good to take a look at state of the art. We want to build something with state of the art because then, even if something goes wrong with our project, we can still take our knowledge and apply it to other state-of-the-art frameworks. And here I'm going to give the example of Apple Swift UI. So we've got a very simple application, which has a counter and a button. So the counter is at 0 and the button is below. So if we look at the code, we see that we have a state variable that has the counter value, and then we've got a text label that outputs that value. And the button below has a event handler, which increases the value, and a label for incrementing. So those are the 2 UI elements. So let's see that complicated beast in action. So it all starts when we push the button. And then the action handler fires and increases the state. So now the state has changed. And because the state has changed, the framework now goes ahead and repaints, redraws the UI. Now, in the UI, really not a whole lot has changed. Really, it's just a single element that has changed our label with the counter value, which increased from, yes, you guessed it, 0 to 1. So what do we just see? Well, we saw 3 different things. Number 1 is we saw our code here as front end being built as code with the builder pattern. In the past, people have constructed UIs with visual design tools, on Apple and other platforms, Windows as well. You had, template files maybe for HTML. You had visual design builders spitting out different files that were separate from the code. Not anymore. You mix your code and your user interface. And at first that sounds like a bad idea, but after a while you get the hang of it and you're not going to miss it. There's one particular killer feature that this enables, and you'll see that later. Okay. So front end is code as the builder pattern. Next one is we've got the state component has a state. It's baked into a component. It's got events. Neither of those are revolutionary concepts. Not here the first time, but consequently done here. The component has state and reacts to events. And the last one is that whenever we change something here, the platform redraws the front end. So we don't go out and say, well, text label update. The platform does that because we change the state, and so the platform goes off. So declarative front ends, really 3 important takeaways here. Number 1 is we build our front end as code with the builder pattern. Number 2 is our component has state and reacts to events. And number 3 is the platform redraws the front end. We're not doing something, imperative. The platform updates, and we just need to make sure that we're ready. Okay, and because that's important, let's put it onto our summary slide. Now, who's using that approach? Well, I told you it's Apple, so Swift UI is used on macOS and iOS. .NET has something similar called MAUI, I think Modern Application UI. It's going to come in November 2021 because Microsoft is never going to miss a deadline, right? And just today, actually, in the news, you may have heard about it. Android, there's a tool on Android by Google called Jetpack Compose. And just after a year, I think after 2 years being in alpha, it now entered beta. And of course, in the web world, we've had React forever that use that approach. Really all major platforms, except for Linux, and maybe there's even something there, use this new paradigm. So to summarize our front ends, the web frameworks, we've got 3 of them, Angular, React, Vue.js. We've got 4 cross-platform frameworks, Flutter, JavaFX, React Native, and Xamarin. And state-of-the-art are declarative front ends. Okay. So now we answered the first question, how can we build front ends today? And now, so how should we go about that? And so since we're Java developers, we're going to put together a wish list. And on that wish list, we put all the things that we wish we'd like to do when building front ends. So the first one is, of course, we want to build stuff in Java. We're Java developers. Now that we know declarative is the way to go, we want to build UIs declaratively. We want to pick something that's safe, that's still here 5 years from now. We want to pick something that's popular. We want to build web apps, mobile apps, desktop apps. We want something that's complete so that we don't need to, hunt for plugins or extensions. We want something that's fast, that gives us all native features, that has one code base, and that gives us a fast build, deploy, and debug cycle. Okay, so why am I going on about popular? Why is that so important? I think there are 4 reasons for that. Number 1, if something is popular, it makes it easier to learn because there are more tools, there's more books and courses out there. Number 2, it's easier to build, deploy, and debug because there are more tools for that, and there's more support in our IDEs. It's also easier to hire because there are more developers who know those frameworks. And last but not least, it's hard for you to use tool Y if everybody says, well, X is clearly winning. So you're fighting upstream there. So popular is really important here. And that's why our wish list goes onto the summary slide. So first part of the second question answered. Now back to our scenario number 1. I hope you still recall we wanted to build just a web application and we had these 3 frameworks. So let's look at popularity, starting with Google Trends. So here are the Google Trends. So first of all, the Vue.js is probably underrepresented because if you just search for Vue, then you get lots of other stuff. So I think Vue.js is more popular than what you see here. But the other 2 frameworks, we get usable data. So we see over the last 5 years, Angular and React both decreased, but React clearly is in the lead. Okay, now let's look at Stack Overflow. Okay, there the picture is a bit more decisive. We're seeing Vue increasing, but leveling off at its current level, Angular decreasing for about 3 years, and React still going strong. Now, the number of questions Stack Overflow doesn't doesn't always mean it's a very, it's a better framework, because, maybe people ask questions because there's stuff wrong or documentation is incomplete. But I think general people take that as an indicator of popularity, and so do we. So if we just kind of summarize the popularity of the web frameworks, we see React is most popular, Angular is second and shrinking, and Vue.js is last and growing or flat. So now let's score these 3 web frameworks according to the wish list that we put together, these criteria, those 12 criteria. And really not all of them apply, because we're talking about a web framework. So who wins in these categories? Well, coming to Java, none of these have Java, but Angular is closer with TypeScript to Java than the other pure JavaScript frameworks. The only declarative framework here is reactive, so it wins that category. Safe, I think that React is more safe than Google's framework and Vue, and I'm going to talk about that a little bit later. That's probably a bit subjective. React is more popular. That's objective. I think that for the kind of web applications that we're building, all 3 applications produce fine apps, so there's no winner here. Angular is the most complete package, which is where some of the complexity comes from. For instance, with React, you don't get a router component. You have to put one yourself, get one yourself. They're popular ones, but Angular is batteries included. Fastest is, I want to say, React, and there are some things there that I'll put into the additional material. It has some features that make it faster. And for build, deploy and debug, I don't know, because I don't know these other 2 frameworks. So I can't tell you who the best one there is. And so now if you're ranking based on this wish list, and we see that React wins, Angular is second, and Vue.js is last. And so that leads to my first advice for web, first scenario, just building a web application. What's my advice? My advice is, if you already use React, Angular, or Vue.js, then keep it. We saw a ranking here, but none of that is knockout. They're all fine frameworks, so that's that. But if you start from scratch, if you can choose, if you can pick your framework, then go for React, then Angular, then Vue. And summary slide. And so second question, we've got that answered a little bit. And now let's turn to scenario number 2, our mobile apps. Hope you still remember we had 4, doing the same exercise here, looking for popularity, starting with Google Trends. Again, we're looking at the last 5 years, and what we're seeing here is Xamarin and JavaFX declining, React increasing, but Flutter overtaking it. Both took a little bit of a Corona dip last year, but it looks like Flutter is climbing out again, whereas React stays somewhat flat. Now let's look at Stack Overflow. With regards to JavaFX and Xamarin, the picture is the same, decline for a couple of years. React here is still growing, but Flutter is clearly in the lead. So if you want to summarize the popularity, Flutter most popular and growing or flat. React Native second, either shrinking or growing. Xamarin is third, shrinking or flat. And JavaFX is last, shrinking or flat. And so because of that, I have to say, I'm going to throw Xamarin and JavaFX out. You're voted off the island. Why? 3 reasons. Number 1, neither of these frameworks is declarative. We said declarative is the state of the art. We want to use state of the art, so they don't give us state of the art. They're both not popular enough, and they're both not safe enough. In fact, we know Xamarin, it's going to be replaced by something else in November, and JavaFX just backed by a single company. So that goes on to our summary slide. And so then there were just 2. Now, I said that I'm in the abstract. If you read it and you see that I'm going to be talking about Flutter. So what actually is Flutter? Here, let Google say it in their own words. So the keyword really here is number one, beautiful, which really means fast and animations and fluid. And you see some of that. And later on, natively compiled, we like that. Mobile, web, desktop, single code base, wonderful. What's not to like there? Lofty aspirations here. So what's my Flutter experience? I built a prototype in the summer of 2019 in a couple of weeks. And I'm working on a project for iOS and Android since September 2020. And another disclaimer, I only cover Flutter on mobile in this talk. Okay, so let's compare React Native and Flutter. React Native uses JavaScript, which we don't like. Flutter uses Start, which we do like. You may not know it yet, but you will. More on that later. React Native has slower rendering. It goes through a JavaScript bridge. Flutter is much faster. On mobile, it uses the Skia rendering engine that's used by the Firefox and Chrome browsers, so really paints pixels pretty fast. React Native uses the native UI elements, so the buttons and the text labels and stuff. Those are really iOS or Android elements. Flutter does that not. Flutter emulates the UI elements. So when you see Android or iOS elements on the screen, text button, all of that is built by Flutter, and that leads to issues. That's why I don't like it. There is no desktop support in React Native, at least not officially. Flutter covers all devices. React and React Native is actually two different things. So if you want to cover the web and mobile, you've got two different projects, React for web and React Native for mobile. In Flutter, you do have one code base, so that's good. And that's why this goes on to our summary page. So now, what kind of front ends can we actually build with Flutter? That may sound like a strange question, so let me enlighten you. There's really three different ones. Number one is we can build our own brand, right? So, if you use Netflix, then Netflix always looks like Netflix, no matter whether you open it up in the browser, as I did here, or if you open it up on an Android phone. So the UI looks similar, the fonts, the colors, typography, everything is the same. They don't really care. Even if you run it on a toaster or fridge, Netflix looks like Netflix. So you don't care about the underlying operating system. You observe that. Number two is material design, which is Google's design language. So Google products all use that. So that's why Google Maps looks like Google Maps again, no matter where you go. And it's considered the native UI on Android. On Android, you've got different vendor skins that change the UI. So Material is the native UI. If you need a refresher, what it looks like, here we go, typical form. And the last one is, of course, you can strive to build a native UI. Native UI means, you've got Windows 10 File Explorer here, or the app that I'm working on looks like native iOS application. So now that we know that, can Flutter really give us a mobile, web, and desktop from one code base with Flutter? Here's the answer. So the answer is yes, with two big asterisks. Asterisk number one is really production readiness. So which parts are available today? So we've got our platforms here, and I'm going to throw in web because that's a platform that Flutter targets. Mobile is the best. It's been in production since December 2018. Wonderful. Web has been beta since December 2019. Mac has been alpha since that same point in time. Linux entered alpha last July, and Windows only last September. Okay. So now going back to what front ends we can build with Flutter, that's the second asterisk, right? So if we want to build our own brand, then can we do that across these 6 platforms? And of course, yes, we can, because we just paint pixels. We don't really care about windows and buttons. We do our own. The same is true for Material. Google gives us Material on all of these. And finally, we've got native, and that's where the illusion cracks. So on desktop, you cannot build native applications. So you cannot build a native Mac, native looking Mac, Windows, or Linux UI with Flutter. Neither can you on the web. So for these platforms, it's really just a Material design. On iOS and Android, though, you do get native developments, native UIs. So to sum up, Flutter from one code base, yes, on iOS and Android. On web, it's just in beta and no native UI, and desktop is in alpha, so at least a year away from production, and also no native UI. Now, some of that may change on March 3rd, because that's where Flutter Engage takes place, the annual conference. So I think it's next Wednesday. So my guess is that maybe they're going to put web out of beta and make it production ready. Now, we talked about Dart quite a bit. And so, as Java developers say, oh, God, not just another language. Can we just use, Java instead of that? Because, in the end, all we want to do is we want to write Java code that looks like that. Now, the interesting thing is this is actually Dart code. And if you're eagle-eyed, you may have seen the one place where you notice that it's not Java. This compiles as Dart. It does not compile as Java because of this here, right? So you can't instantiate an abstract list class in Java. So what you already see here, well, what is Dart? When we come to the question, what is Dart? Google built it originally for the browser. But what we see is that it's really a simplified Java. Simplified is, for instance, you can leave out the new keyword. There's only public and private in visibility. There's no interfaces, but you've got abstract classes. There's no lists, but only arrays. You don't have simple type. Everything's an object. So really, a simplified Java. But on top of that, they build useful changes and enhancement. For instance, there's concurrency with async await, really easy. You've got optional named and default parameters when calling into methods, and you've got some syntactic sugar for dealing with lists and arrays in your user interface. And that's really, important here, because really Google develops Dart just for Flutter these days. So they go hand in hand. The same way that, for instance, Apple can push its language Swift forward and its operating system, Swift and Swift UI. Now, another thing is that just like, I guess, GraalVM, when you develop, the Dart code you write runs in a virtual machine. But when you deploy your application, it runs as native code in production, and that enables a nifty feature. So how does Flutter actually run? There's two ways you can run Flutter on mobile. Number one is you can just run it as a standalone app, put it into the App Store, or you can use it just to add some screens to a native app. So you could, just dip your toe into the water, take your native app, build some stuff in Flutter, in your native iOS or Android app. Now, one thing that really stands out is that there's a fast build and deploy here. So what do I mean with that? If you build for mobile, if you develop for iOS and Android, then mobile build times are really long. It's not uncommon to wait a minute or two until your code's compiled and running on your device. So Flutter deals with that in two different ways. There's something called hot reload, which shows the changes immediately. And then there's hot restarts, which resets your app in typically 2 to 3 seconds. And both of those things are faster than native Android or iOS development. And so let me actually show you. Wonderful. So what did we just see? We saw that really hot reload is fun and keeps the flow. So what do I mean with that? When you develop and you wait for your application to compile and deploy, it's not uncommon to wait for 30 seconds, a minute, two. And in that time frame, your mind wanders, maybe just quickly check Twitter or the news, and your flow broke. with Flutter, and I think React Native has something similar, that usually doesn't happen. You make a change, it immediately appears, and you can go on. And so you keep the flow, you can just go building, and it just makes it fun. I'm not sure of any other way to describe that except for the word fun. It also comes with dev tools. Flutter, I've just barely used them. You can use them to tune your app, and it's the tools themselves are actually Flutter web app. You can see them here. So at the top, you've got the hot restart and hot reload buttons, and then you've got this whole line underneath it. So you see stuff like the performance analyzer, because Flutter, they really want a fluid 60 frames per second user interface, so they tell you when you drop frames in your application. But again, I haven't really used that at all, really. Plugins are pretty big in Flutter. They add functionality, something that's missing, or they plug some holes in Flutter's functionality. Most of them are open source, and they've got a great plugin portal. So, that puts Maven Central to shame. You also want to integrate with native stuff. How you do that? So you do it through plugins. You find plugins for camera, pictures, files. You can also show native screens in Flutter if you want to. And if you have to, you can talk to native code through what's called channels, really. It's publish and subscribe. And this way, for instance, you can exchange messages, put out geofences, get notifications. There's even a C API. Now, sometimes you have to fix plugins because the plugins has bugs or is not maintained, and that's especially easy with Flutter. It's really just 3 steps. You fork it on GitHub, you make changes in the fork, and then you use the fork git URL in your Flutter build file directly, and voila, you're using your own version of that plugin. So, summarize the good parts of Flutter. It's a fast code build and deploy cycle with Dart and tools. Plugins add functionality and plug holes. Native integration is easy, and everything is open source at GitHub, the plugins, Flutter itself, so you can see the source code, the issues, and everything. So what are issues? I'm going to list 3 here. Number 1 is, of course, it's a Google project, so everybody asks, when will Google kill Flutter? And Google has a well-earned reputation. Their entire website's devoted just to the projects that were killed by Google. We see some here that you may know, AngularJS, for instance, Google Hangout. And of course, the answer to that question is nobody knows. So we just look for indications. Number 1, what's bad is that we've got competing efforts at Google. I already told you about Jetpack Compose, which roughly is Flutter just for Android. We've got Angular, which also wants to build for, native and web. What's good is that Flutter is actually pretty popular outside of Google. So in 2019, it was listed number 3 at GitHub for number of contributors, more than 13,000. And then there's this mysterious project Fuchsia of Google, where Flutter is actually the UI layer. Okay, but still nobody knows if and when they're going to kill it. Now, another thing that's annoying is in Flutter, there are 2 ways to arrange elements on the screen. You see my app here. You've got a column, which is a vertical list, and you have a row, which is a horizontal list. But it's not responsive. Flutter by itself is not responsive. So what happens if somebody rotates the phone or uses a big phone or tablets? What do you do then? Well, you're on your own, because Flutter only gives you the screen dimension. So how did I deal with that? I used a plugin that gives me a bootstrap kind of responsive grid, and that's why my application now redraws the UI, and I don't have to go in and switch rows for columns or something crazy. The last one, my last big gripe, is native UI building is too hard with Flutter. There are some of the iOS UI elements missing. There is no list or table view. The form is incomplete, and it's just too much manual assembly required. So there are a couple of plugins that add missing elements and add some abstractions on top, but then you still have to build your own abstraction on top to say, here's a screen that looks like an iOS native screen or an Android native screen. So to sum up, the bad parts of Flutter, will Google kill Flutter? That question will always be there. There's no responsive design built in, and putting together a native UI is too hard. If you build your own brand, if you use Material Design, you're fine, but the native UI is harder than it should be. So let's score the mobile apps frameworks. Here's our wish list. When it comes to Java, no contest, Flutter wins. Declarative, they're all both declarative, so I don't think there is a winner. I think React is safer from being killed than Flutter. Flutter is more popular. I think for web apps, React takes the lead because it's been around longer. For web, Flutter is just in beta. Mobile apps, I think it's a wash. Desktop apps is Flutter because React doesn't support desktop. Complete again is Flutter. React doesn't have a router, so you go plugin hunting. Flutter is faster because it uses a rendering engine. I think they all give us native features. One code base is Flutter the winner because React is two, one web project, one mobile project. And I'm not sure whether who's the winner for build, deploy, and debug. So for ranking number 2, mobile apps, Flutter wins. React Native is second. And just to recall, JavaFX and Xamarin are out. So my advice to you is if you already use React Native or Flutter, then keep it. If you don't, then go for Flutter first, then React Native second. So we're nearly done. You say, oh, Jesus, we've got 35 minutes and we still have to cover desktop. Well, that's going to be pretty quick. Why? Because desktop is a waiting game. There is no good cross-platform option right now. And at the same time, there's lots of changes going on. So in Windows, we've got .NET 6 coming up in November, complete rewrite of the whole infrastructure. Microsoft introduces Fluent Design. On the Mac, we're just migrating to Swift UI, and they also introduced changes in the latest macOS version, visual changes. So it's really not fun being cross-platform on desktop today. And on the other hand, web is good enough on desktop. That's why my advice for desktop is as follows. Keep your web application for your desktop. And only if you use Material Design on desktop and you use Flutter, then you should evaluate, or you could evaluate Flutter for desktop next year. Okay, so now our summary slide is nearly filled. We've got our question answered. We've got one spot left, and that spot is for the question, do I actually follow my own advice? What am I doing now? I'm giving you advice. Do I follow it? And I do. So yes, I'm currently using Angular on a project, but I learned React for a side project and hope to just use React going forward. For mobile apps, I use Flutter for iOS and Android. Yeah, I already told you that. And for desktop app, yes, we just use the web application. We're not doing anything special. So here's the wrap up. And so let's talk about the 3 scenarios. I told you at the beginning, I want to give you advice for the building a web application, for adding mobile apps to an existing web application. And I said I'm going to tell you what to do on desktop if you have a web application. And so let's take out our big summary slide to kind of cover our journey. So the first thing that we talked about is that you need to apply your own criteria. I'm giving you advice, but you need to be smart, your own criteria. So please don't sue me if your Flutter project fails. What kind of applications were we talking about? Well, we said something like expense filing or an issue tracker across PC and mobile. We found out that declarative UIs are the state of the art. We built front end as code, got state and events, and the platform redraws it. So we only indirectly affect our UI. Then for the front ends, we found out that we've got 3 web frameworks, Angular, React, Vue. We've got 4 on cross-platform, and declarative is state of the art. Then we put together our wish list, a set of criteria specifically for us Java developers to judge the frameworks by. And with that wish list applied, our advice was to keep React, Angular, Vue, and if you can choose React, Angular, or Vue in that order. We threw Xamarin and JavaFX out because they're not declarative and they're neither popular nor safe. Then we compared React and Flutter and found out that React is better from our perspective in every regard, except for the UI elements. It emulates UI elements, and that leads to issues. And the promise for Flutter to have one code base is only partially true. It's true for mobile, which arguably is the most important market right now, but not for web, not for desktop. We looked at Dart and surprisingly found, hey, it's a lot like Java, but simplified and enhanced for UI building. Then we looked at the good parts of Flutter, of which there are some. So we've got a fast code build and deploy cycle. Plugins are good. Native integration is easy and everything is open source. And then we looked at the bad parts. Will Google kill Flutter? That by itself could be, a killer criteria for some project, which, eliminates Flutter. There's no responsive design built in, and putting together a native UI, which some of you may do, is just too hard. Based on that, the advice was, if you use Flutter React Native, keep it. Otherwise, go for Flutter first, then React Native. Last advice was on desktop. Keep your web application on desktop. Only if you use Flutter and only if you use Material Design, then evaluate Flutter for desktop in 2022. And do I follow my own advice? Yes, I do. I'm switching to React. I'm using Flutter. I'm just keeping my web application. Well, that's the end. Well, not really. One last thing. I'm looking for work in October 2021, either as a contractor or fixed term employee, Milton Keynes, London, or remote. So after that plug, here's the page that I talked about. As I said, you can find more information, slides, video, get started, my newsletter, everything on that page. Again, please be patient. The site is not updated yet. I'm going to put some more stuff on there today. I think you already had the link being shown. So are there any questions? I'm going to stop sharing my screen now because otherwise, no. Here we go. We are back. So hit me with your questions if you have any. And thank you for your attention.
Yep. In chat earlier during your presentation, there are two people asked about two different frameworks, I believe. Are you familiar with Varden or Timeleaf? What are your thoughts on that?
Yeah, I'm familiar with Timeleaf. Actually, one of the applications I built, the first one, it was a Timeleaf. Timeleaf is an HTML template language popular with Spring Boot. I guess the reason, so yes, it's a perfectly fine framework to use, but it's not, it's a plain HTML template. I think the trend today is to build single page application. And that's why I think something like, React or Angular Vue is the norm. You can still build, regular server rendered web pages, but I think the trend is to build single page application with these JavaScript frameworks. And by the way, if you, in case you're curious, both of them, at least Angular and React, I'm not sure about Vue, they can do some server-side rendering as well. React probably a bit more than Angular, but you can do a little bit server-side rendering as well. The other framework, Varden, I'm not familiar with that.
Thanks for that. The next question is by Alan. Flutter has recently had an issue with jank apps, an issue that has been reported 3 years ago and not fixed yet. Do you think that the community support can be a big no-no for Flutter?
Okay, so that's actually a good question. So the question is number one about jank and number two, community support. So what jank really talks about, what jank means in the concept of, in the context of Flutter, of mobile applications in general, is that you don't get, that your UI stutters. Flutter targets 60 frames per second for fluid motion, and sometimes if something happens, then the UI, stops, doesn't keep up, and that's, jarring to some users, and that's what jank is called. So that's what jank is all about. So I think there are some people that say that Flutter is doing too much too soon and they're expanding too fast, and that's why they're dying a death of 1,000 cuts with lots of bugs not being updated. So I haven't hit any showstopper bugs myself, but it could very well be that I do. So the thing that actually did surprise me in the mobile space, I've been mostly backend developer, is what kind of crappy software quality companies deploy. I mean, iOS 13, was a heaping pile of shit, pardon my French, when it was deployed. It didn't work. The camera app crashed, and then iOS just I think early last year they deployed a version of iOS in production, which kept every developer that wasn't a professional developer from deploying the apps because of some certificate issues that went unpatched for a couple of weeks at least, maybe even a month. So I'm kind of shocked on what kind of shoddy code gets deployed out there. So I think from that perspective, it's maybe a bit more forgivable that there are some crappy bugs in Flutter as well. But of course, it doesn't help you if you're hit by that bug. The one thing that I did notice is that a couple of months ago, Google hired an outside company to deal with some of the plugins that they couldn't maintain themselves. They had a bunch of first-party plugins around, Google properties like Google Maps and Firebase, their mobile platform, and they were in pretty crappy state. So they hired somebody to take care of that. So my hope is that, if they see the community complaints that they're not fixing bugs enough, they're hiring some more, talent there. They certainly have the money. As far as commercial support, I don't know whether you can get commercial support for Flutter. There may be some agencies that offer that, but I'm not sure whether either Google or somebody else sells commercial support for that. Again, there may be some, announcement in that area, coming next Wednesday on that annual Flutter conference.
Thanks for that, Karsten. There are two questions asking about your thoughts on Kotlin from Alan and Jeremy. What are your thoughts on Kotlin for front-end apps? And do you think Flutter made a mistake deciding to create a new language instead of building it on languages like Kotlin or JavaScript, which are already popular among mobile devs?
Yeah, that's a great question. So Flutter went back, I think they started in 2014 or 15. And so when they looked at the languages, decided what language to use. And they picked Dart, which really was an in-house language. Google originally built it to run in the browser, and it didn't. And so I think what advantage that Dart has to Google, I think there's really two advantages. Number one, they can shape the language whichever way they want. If they were to use Kotlin, they have to convince the IntelliJ guys, right, JetBrains, to do something, because in essence, Kotlin is a language that's ruled or steered mostly by JetBrains. So you have to convince somebody else to put something in the language that just benefits you. So that's one thing. The other thing I think that drew them to Dart is that Dart really can compile to pretty much anything. So you've got, in Dart, you've got a virtual machine just like in Java, but you can compile Dart, to JavaScript, which they do on the web. You can compile it to machine code. You can compile it to pretty much everything. So it gives them, a nice development experience, because you've got this hot reload. It runs in a virtual machine, but when you deploy it to production, you can compile it to any platform that you run on. So those were really some good things. And when they started Flutter, I'm not sure that Kotlin really was around or really stable in that option. Kotlin, I think there are some efforts to use Kotlin for front-end development. And I think, check out these efforts. From my perspective, it's when you look at the frameworks, the cross-platform frameworks, my recommendation is to go with the big ones, right? And the two big ones are there. So Kotlin definitely is more of niche, but maybe that's, important for you because it's much closer to Java than Dart. But, Dart is already pretty close to Java. So you're not losing a whole lot, or you're not gaining a whole lot by switching to Kotlin.
Thanks for that, Karsten. And finally, as we are Java developers, this is from Mo, who are used to imperative programming, why is declarative programming the state-of-the-art standard in a front-end framework?
I think one way of answering this question is because all the big guys are doing it, right? If you recall my slides, Apple is doing declarative programming. Android is about to do it. They just today put the Jetpack Compose into beta. So they said this is our new framework, essentially the Swift UI for Android, and Microsoft is doing that as well. They still run the imperative, but they also give you that declarative option. So from my perspective, it looks like the whole industry is moving this way, with Windows, macOS, iOS, and Android all doing the same thing. So from that perspective, whether you like it or not, really it is state of the art because it's what everybody is doing. I think in some respects, I think it makes development easier, or at least it can lead to higher productivity, because as you saw in the video, you can make changes in the code and then your code immediately runs. And as soon as you just design your code and your user interface separately, you can run your user interface, but it never has your real data, right? It's a simulated UI that you see. So I think to me, the exciting thing here is in this declarative and Swift UI, they all do the same thing. It is your real code that's running in the simulator or the device. And whenever you change either your code by providing new data, or you change your UI, you put a new field on the screen, in both events, your simulator or your device immediately updates. And that's really a nice development experience. And you don't, that's harder to get if your code and your UI are, in separate files, or maybe even, in separate tools. But if I had to give one answer, I would say it's because everybody is going towards declarative programming. So, that's the reason.
I think that's the last of the questions. Yeah, thank you, Karsten. Thank you, everyone, for the questions. And thank you, Karsten, very much for your fantastic talk. Thank you.
Okay.
There's a little applause. And Sarah had to dash, but yeah, both of you have given fantastic talks today. Thank you so much. I learned a lot myself. I think I'm gonna go check out Flutter now. Yep, Karsten has just posted the page for the talk. There will be slides, and Sarah will also share her slides with lightning talks with Barry possibly, and the slides will be sent out to all of you. Jeremy, I just had a quick question. Did you use a special tool to make your slides?
Yeah, it's Apple Keynote. The thing that is maybe, I don't know, PowerPoint, but the one thing that makes things kind of zoom out, and these transitions, something called Magic Move. That's a feature that is quite popular in Keynote. So just one more thing. I said the page is incomplete, the talk page. You can go there today. What you can find there today, what is already there, is the links and stuff to get you started, with Dart and Flutter. So I've posted links to courses, online courses, free courses. If you want to get started with Flutter, you can find information on the talk page. What I still plan on adding is two things. Number one, resources and getting starting with React, because that's my other recommendation, and I'm learning that right now. And number two is, some details, three things really, some details about the, specific Flutter plugins I'm using, I would recommend. And then number three, some additional material in some of these places where I said, for instance, hey, React is faster. There's a couple of reasons why I think React is faster. It's got some features, so I want to put in some additional links. But if you want to get started with Flutter today, because you feel all riled up after my talk, then you can go ahead to the talk page and you find all the links you need. And the slides are going to be there as well tomorrow. So
fantastic. Thank you, Karsten. And thank you, everyone, for sticking around. I haven't heard from Barry about any slots being filled for the next lightning talks, but if any of you are interested in giving a talk for 5th of March and 19th of March, there are spots remaining according to the last newsletter. So be sure to email Dom about it in RegWords. Thank you all for coming. Thank you so much.